Hello guys, welcome to AIology. It's about 9 months that I'm uploading video in name of 10 minutes paper. Before that, I had some videos related to writing some codes based on some papers that was not written by the authors, or it was not easy to find the open source code repository. So Recently, I created a poll, and you voted that most of the interest you are following is related to writing some codes, walking through some libraries, and creating some stuffs. I will continue on those 10 minutes paper because some of you voted on that parts too. But I have decided to be more uh, to create more friendly videos to chat with you, and also I learn from you too. So during this series, I will walk through some libraries in programming language like in Rust, in even some front end development like using Svelte, stuff like that. But most of them, they are connected to the artificial intelligence. So in this series, I do not try to edit the video, so I may have some mistake and errors in my code. As I said, I'm not professional in all of these, but we are trying to uh, get familiar with some tools together, writing some codes together and seeing documentation, learning from there. And yeah, let's start. This session, I want to walk through Cython. Let's see what it is at first glance. So I can say, what is Cython? So as I said, I have not prepared for this kind of video. This is like a stream video, but I have recorded that. I'm not editing that. I may read some things before, but I'm not professional in it. Cython is an optimizing static compiler for both the Python programming language and extended Cython programming language based on Pyrex. It makes writing C extension for Python as easy as Python itself. So there are lots of cool things that we can do with Cython, like write Python code that call backs and forth from the C or C++ code. And this is important that both C and C++ is supported. Another important thing is that it is easily readable Python code into plain C performance by adding a static type declaration also in Python syntax. So we will walk through some of these. Also, there is documentation. We walk through some of those documentation too. So actually, we will see just by adding some static type declaration, we are improving the performance sometimes by, I can say, twice. There are some codes example in documentation. We will see them. Um, Use combined source code level debugging to find bugs in your Python, Cython, and C code. I haven't seen that documentation yet. Maybe we can walk through it. And yeah, lots of things here. So what I have prepared for now is I have created an open space in Visual Studio Code. So I want to create a Jupyter notebook. So I can say IPYNB. Okay. So I selected Python 3.8 as my kernel. So the thing is, if I want to load Cython uh, in IPython notebook in Jupyter notebook, so I can say load external, and I can say Cython. Um, if I run this, so I'm able to load Cython functionality here and here. If I say I want to use Cython, so I can use Cython variable. For example, for Cython, we can say define an int variable one and call it equal to 1. So I'm using GitHub Copilot. So if you see some code hint, this is because of the Copilot. So I have defined the int variable. If I create another cell, I come here, I say what is variable 1. I'm not able to see that because each Cython we write here, uh, it means that we are defining the scope of that C variable. This is writing a variable 1 in a stack, and even if I write Cython here, we are not able to call that variable one. It said undeclared name not built in. So even though we have defined it here, we are not able to call it in the Cython in another cell. So this is important part that we need to know. So if I convert it to somehow to the Python variable, it go to the Python scope and GIL, we will talk about it. We'll get it, the global Python interpreter will get it, and we will be able to use it in another cell. But for Cython, we are not able to do it. So uh, we know that C variable um, has a pointer, so we can define a pointer point to this variable. How we can define that? Actually, we know that in C we can say var1, and we should be able to see it. But the problem is if I want to say print this variable, I shouldn't be able to because it said cannot convert int, this is a pointer, to the Python object. So we need some sort of casting to convert this to Python object. What we can do for that, we can use typecasting like this. And for that, I can say uh, convert it to something like unsigned, unsigned variable. So I will put this in parentheses just for clarity. So you see that it said uh, this is the address of that variable. Usually we like to see it in hex. I can use any Python function now because it is converted to unsigned. Uh, I declared the variable. So yeah, you'll see that the location of the memory pointing to this variable is this one. This is cool, huh? So um, actually, I can define something like this. I can say var1 pointer, and I can get this var1 um, address of the memory and put it here. So uh, one of the things, if I just run this, you'll see that it can be run. And if you see, this is the warning and error cast from pointer to integer of different size. We should be able to handle this kind of error. We don't want to have any of uh, and we don't want to have any of these error. And yeah, so what I want to show here is that in C we are able to change this variable, and by changing that variable we are able to change the original variable. So in Python, again, this is in C, so we are not able to access it. So if I do something like var pointer and I increase it by 1, I just want to see if var is changed or not. So it is still 1, even though I have increased this one. So this is a pointer. This is like an array, I can say. This is pointing to one part of the memory. So it would be an array in size of the memory if I have like uh, I don't know, 10 megabytes of memory, uh, it would be array in size of uh, from the point I'm pointing to end of the memory. So when I say number 0, it would be exactly the pointer I'm pointing to. So if I do something like this and I print it, you see this is now 2. The variable is 2. I changed this one. I changed that part of the memory, increase 1 to it, and it's same as I changed this variable 1. This is exactly same as what we do in the pointer and reference in C. So we have the pointer, we say what is variable inside that pointer, increase 1. And if we see that variable again, we see that this is increased by 1. So this would be same as when we say var1 is equal to var1 plus 1. These are equal. So what else we can do? So actually, when I say this, when I say variable one is defined here, but I cannot access to it because implicitly um, it is doing something like get this var pointer and assign null to it. So we don't have any variable there. So by doing that, we don't have access to that pointer again. This is done implicitly when we have this Cython cell here. So this is another point that we can do it in Cython. So let's now write something more interesting. I want to write a quick sort and um, show you that how we can call a function, pass some, for example, an array to a Cython function and get the result. And during that call, we can use some of the function from Python, pure Python. So again, I need to say this is a Cython, and interestingly, I can import from standard library of C. I can import from libc or even C++. This is available. For example, you see the GitHub Copilot can estimate, we can say libc++.vector. I don't want a vector for now, but I want to see a standard library. I don't want a malloc uh, allocation. I can import, uh, let me write it, C std library C import. See the difference in Python, we have import, here we have C import. And I want to have C allocation. What else I want to need is a random variable and a rand max, the maximum variable uh, we have by random. So I want to define a function. You see, for variable, we define cdef. Again, we define cdef, but we need to define the output like output type like in C. So we want to create a sort function. Let me see that GitHub Copilot can help us. Quick sort in Cython. And if I just remove it, I can say def void quick sort. Yeah, cool. So it get left and right variable. We get an array. Just for simplicity, I just want to change this to double and change this. It can be int, it can be size t. We can have access to anything here. Just want to show you that this int that is showing here is in different color. It's not because of the Cython. There is a name in int in Python, and my interpreter assumed that int is the same as the Python one. But we can use any type in C, so that's why I changed it just to clarify that. So um, let let's check that it can GitHub Copilot can create something for us. No, it will wait until we define something. So for this one, we need to define a variable called different variable like ij and pivot exactly. Another thing we need to define is a double temporary variable. And we can say if low, we have left and right. So if left is smaller than high or right, so that's GitHub Copilot is writing for us, which is cool. So the pivot in that case should be equal to left, and I is equal to left, and j is equal to right. That's right. So I can say while I is smaller than j, and while array, yes, that is right. And I think it should be equal. This is a quick sort algorithm. If you don't know it, you can just search it on the Google. I'm just writing it and see. You can copy and paste from different parts on the internet. Um, yes. So We need another while. Cool. Yeah, I was looking for this. Oh, cool. It's right many things. This is cool. Um, I want to keep that for now. So we have written this. Let's see just if it's right or not. So we have temp, we have array pivot. Yeah, everything is right. So we have the quicksort algorithm, and we are using a CPython. Every syntax here you see is C. And then we define the variable double an array, and we use the C allocation. We say 100. I don't need 100. I can say 6. And just for simplicity, maybe I can define that size, cdef size t. I can say it is array size, and I say 6. So I can say define based on the array size and array size minus 1. That's it. So if I run this, uh, if you see this, this is an array and this is a pointer. And just for having a floating number, I'm gonna modify this. So we do the quicksort and we pass that pointer. So every change we do this on array will be change the array here on this scope. So when we print it, we will see the uh, sorted one. So there is a problem here. It's that okay, yeah. This is a syntax problem. Should be something like this, same as this one. Cool. Another problem is that yes, cannot convert double to Python object. This is interesting. So actually we cannot do the print because we need to typecasting again. But what we can do for now, we cannot print it because this is a C object and we cannot convert it to the Python. One of the simplest thing that we can do is that uh, we can walk through the array and print each variable there. So one of the other thing before doing that, let's check that. So when I say a variable here, in this case, maybe I don't have any variable in Python, but if I do something um, by on this variable, the Python interpreter had have something. Python interpreter has something called GIL, global interpreter lock. Global interpreter lock is just locking some of the variable that other threads cannot access to it. So if we have a poor C function, uh, or better say, in most of the Cython function, it's good to say no GIL. And with no GIL, it means that Python interpreter and Python global interpreter lock do not take any responsibility about this variable in this function. So when we do something like this, we cannot print because when we write print, we are using some of the variable that they are handled by the GIL. So just wondering if I say with no GIL, I print this. Still, I shouldn't be because it is um, it is not a, it is not Python array. But what I can do is I define for I in range in size of the array, I print array. So if I do something like this, I'm just showing, uh, oh, I made a mistake. So actually this should be vice versa. So if I have that for loop, that is okay. But if I want to print that because I'm just printing something that Gil can work on it, So it said that accessing Python global or built-in not allowed without GIL. So it said that you are doing something with this variable that GIL is getting that and you want to print it while you don't want to get GIL. So that's why another way to do it is just create another function, for example, call it run. And by doing that, we are putting everything here inside that and we say no GIL. So now when we say no GIL, we should be able to run it. So if I come here and I say run, let's see. So now we have run with no GIL. So we create these functions and we do the quick sort. Oh, sorry. You should say with GIL. Um, so now this array is not with GIL, and we say when we want to write it, we use GIL. So if I run this, yeah, you see that I'm able to sort 6 different numbers and print them. So this is important that when we run this, we have two garbage collector. One is GIL, the Python interpreter, but to say uh, that manage the variable in Python, and another is the garbage collector in C. So we should be careful about that. So this is interesting. I just want to show you what else we can do. So this is just for defining some variable, stuff like that, and list inside the C. But one of the important things is that NumPy is written in C. We know that. It means that NumPy is like a wrapper around C arrays. And um, if you want to use that C arrays, we are able to do that in Cython. And we can just use .data attribute to extract underlying C pointer. How is that? So let's create another Cython. And here I can say import numpy as np. And again, I can say simport numpy as np. So I have imported numpy from both numpy and C implementation. So suppose that we have a variable x, and this is an np array. This is cool. The GitHub Copilot is helping a lot. So we know, like the first example we had here, maybe we want to have a pointer to that array. What I can do, I can say cdef long. The pointer can be a long list. Yeah, and it can be a list of, sorry, it can be a x pointer and convert it to long and get x.data. What another thing I can do is that this x is actually a np.nd array. So this is np of nd array in C import. I get the data from it, convert it to long. Now I have the pointer. So why this is important? So if I have a function, for example, add one in C, I get the pointer and get the size of the variable. GitHub Copilot is really cool. So I can say for I in range of the size, I add one to each variable in that pointer. So it means that I am adding one to each of these variable. So I can say add one in C. I get the X pointer and the size is 10, but another thing I can do is I say X dot shape 0, or maybe even X size, because this is just one dimension. So if I do something like that, and if I print x. So we're printing x. So it should be what? It should be 2, 3 to 11. You see, we add 1 to each of these variables. So we are able to convert, or better say, get the pointer of the NumPy array, add 1 to each of the variable, and print it. This is cool. We can use uh, this, pass this pointer to any C function and use our uh, C function in Python. So because we use integer here, we use long. If we have like floating point here, it's better to use double pointer, because the type of these should be the same as the type of each of these variable. And yeah, that's another point. Just want to make sure that we are on the page. About the GIL, just want to highlight this, that there are good articles on the internet and they're talking about how we can fix some of the GIL issue. One of them is that Python really doesn't have multi-threaded application, and the main reason is that GIL is taking for example, one of the variable that we need for multi-thread, and it block it, and it cannot be used by other threads until the main thread, the first thread that got that variable, free that object. So that's one of the reasons we don't have real multi-threading application in Python, because GIL lock everything. And by doing that, we are able to do some sort of multi-threading if even in C or C++ if we don't want to use GIL. But there are some changes in GIL. You can see some of the documentation and articles. Many people talk about how we can leverage this and create a real threaded, multi-threaded application. So let's back to the CPython library. Go to the documentation. Let's see what do we have here. So we didn't install anything because we already have that, but if you need to, you can do pip install Cython. That's easy. Um, I think we talked about memory allocation. I, yeah, if you know C, this is very similar for you. Another important thing is that if you are writing in a script, you need to import these kind of things like Cython, symport, libc, stuff like that for using the the C library. But in Cython, if you are using in Cython, like what we did, we add a Cython script here. So it means this is Cython script. And if you are using that, we can just write libc as the lib, and that's it. There is a page here. I think it is interesting to see that. So they have implemented a naive convolution in Python, the pure Python, and they showed that it took about 1.41 second per loop. Then they just add some types. Um, for example, they said npint is a type. We add them, and you see, let's see what types they're talking about. Like here, we define some of these variable in Cython, and you see the time is reduced a lot. One of the main reason is that some part of the code here for interpreter is just taken for understanding what is the type of this variable, because Python is an interpreting language. Another thing they add is the indexing. So when we have an array, of course we can have any shape. It can have any shape and any type, but we can't define what is a type and what is the dimension of that array. That would be helpful, not for some operation, like if you want to use matrix multiplication, it doesn't affect on that. But it has effect when we want to get shape. For example, in this code, we have different parts of the code, getting the shape. And for getting that, of course, this is not that much, but if you run that a lot and we use that a lot, every time it just get the shape and it needs to calculate something, it get the length of that. It would be O1 maybe, but uh, in reality, maybe it's not. So defining this type, it's mentioned in the documentation, I think somewhere here. It said um, the main purpose of things as ND array, typing things as ND array is to allow efficient indexing of single element and to speed up access to a small number of attributes such as shape. Typing does not allow Cython to speed up mathematical operation like adding two array together. Typing does not allow Cython to speed up calls to the NumPy global function to the method of the array. So they just can be used for improving the performance in some of the methods like shapes, stuff like that, that needs to get the shape. So we define them at first. Just doing that, you see, from 800 millisecond, now it is 11 millisecond. This is a lot. So another thing is that they mentioned that they are checking bounds, like when we are doing this kind of indexing here, because this is defined as the CDEF. There are some functionality to check these index these indexes do not go out of the band or be negative. So just adding these to not check those is increasing the performance. It's a little, but it is because it reduces the compiler long list to do to reach to the point that we want to calculate the objective. So yeah, this is one of the important code that we can see working with NumPy array. There are other important things here, like using C++. You can see that I showed you one example that we can use, for example, vector. There are examples here that they use some classes in C++ inside the Python. This is also interesting, and uh, I don't want to make this video longer, but if you are interested in this kind of stuff, if you want me to continue on this documentation, so I can create a video and walk through all of this stuff together, write some of the code, and I think this video would be a good start. I learned a lot from this documentation, and one of the things is that we don't need to learn and know all of these details, because I remember I've used Cython about some years ago, and now when I'm looking at document, I think I'm newbie in Cython. So it is good that if you have any project in your mind, you are doing something, then you come to the documentation, do your stuff. Be sure that you will uh, understand all of the details of it. But this is important to know that you will forget it after some years of not using that. So going to all of the details here uh, is not helping us in the future project if long time is passed, but it's good to know that what capability of these libraries. So in the future, if you have some project, at least we can remember Cython had something like that, so we can use it. So there are cool things here, like using Cython for creating a buffer protocol. And yeah, the documentation I think is good enough to uh, follow that. So you can use CPython also in combination of the Cython. And yeah, defining of a matrix inside the Cython. Yeah, and that's it. There are some other libraries and codes they're talking about that how much Cython could improve the performance. I hope you enjoyed the video. Please share the video with your friends support me by your comments and let me know what you think about this series to help me to decide should I continue on that or uh, I can have a different content. Thank you so much. Have a wonderful day. Have fun.